Dear learners, welcome again to the lectures. So in the last two lectures, we have discussed about few of the concepts of descriptive analytics. So first, let us revise those concepts what we have discussed, and then we'll go ahead what about measure of dispersion. Okay. So what we have discussed in the last two lecture. So first, we have imported the data, and we have used the function read.csv. Okay, and if we have the data in other formats, we can use the other functions. I'll be sharing all those functions with the study material. So after importing the data, we have used the function view to see what data is imported. So what function we have used? We have used the function view, and here view is in the capital letter. Okay, if you will do like this view, all in are in the lowercase letters, it won't work. Okay, so I'll request you that you should try with both the function, and what the output you get, please let us know. Then we have discussed about the frequency. Then we have discussed frequency, and then in frequency we have discussed about that how we can count it, and then we have discussed about the cumulative frequency. And we imagine that we don't know the function to calculate the cumulative frequency. Then we seek the option of the help in the R studio itself. We went to the fourth quadrant of the R studio, and then we have seek the help, and we then we get the idea. Okay, we have to use the function cum sum. Okay, and after that we have discussed about relative frequency, and how we will be calculating the relative frequency, and how we have to use those arithmetic operations. Next lecture I have discussed about this how we can create our own functions, because throughout this course on R we have discussed about lot many functions, but we haven't discussed that how we can create our own functions. So we have created our own function. So if you remember, we have created Mohit one function, then we have created Mukesh, and we have also created Priyanka. Okay, and I requested that always give a some valid name related to the task, so that you can remember that what exactly that function is. Okay, and how it's working. And in functions we have discussed about the function which doesn't require arguments, and some of the functions like add num require argument. Okay, so we have also discussed about the functions which require one argument and then two arguments. Okay, then we have discussed about mean, how we can calculate the mean using the existing function, and then we have created our own function. Then for median we have also calculated step by step, and also by using the inbuilt functions. And for mode there are like no inbuilt functions are there, so we have created our own functions for mode, and we have also seen the whole analysis step by step in our. Okay, so this is how we imported the data. Okay, this was our data set. I have also discussed about the path and why it's very important. And if your current directory and the data where data is existing in this are the same, then you don't have to give the whole path. But in case your current directory is different, but your data is in another directory, then you have to give the full path where your data is. Then we have discussed about this view function. If I I already asked you to try this, like let's see if I do like this view det, and now if I run this, so it's saying that could not find function view. And if you remember, I have discussed in the very starting that what are the things we have created in R, it's case sensitive. So like view all uppercase, or view with one letter as a uppercase, and all other like view word as all lowercase are three different words. So you have to take care of this, that whenever you are calling the function, it should be the right function. Okay, then we have imported the data with the location. Then we have counted the frequency, and we have also counted this table function. So table function is the important function which count the occurrence of particular value. So from here we have counted that for like 2019 there is one, then 2021 there is one, then in 2022 there are 5 occurrence, and then in 2023 there is only one occurrence. Okay. So after that we have saved the data. So once we have done the analysis, we have to save it for as a external source, so that we can show in our presentation, or maybe we can use that analysis in our Word document. And in the same way, the path is very important whenever you are saving the file. So the same way, the function for importing the data which is in the CSV file, we have used read.csv. To save the data which is in the a data frame, and we want to save it as a CSV, we have to use this function write.csv. Okay. So if you see here that many of the functions are task oriented. Okay, their names are based on the task related to that. So if you see write.csv, it's showing that there is a something is there, some data is there, you save it as a CSV file. Okay. Or if there is a data, you read it as a CSV file. So you don't have to remember all the functions. Okay, just you have to see, okay, I have to import the CSV data, so import it, read.csv function is there. Okay, so you will be when you will be doing lot many practice, it will automatically help you in recalling those functions name. Okay. Then we have discussed about the cumulative frequency, and here I discussed about the help that we don't know that what exactly function we have to use for calculating the cumulative frequency. Okay, and then we have moved to this fourth quadrant, and we have seen uh, after searching that we got that, okay, cumulative frequency we will use cum sum. Okay. After calculating the frequency and then the cumulative frequency, we have made a single data frame, and then we have externally saved that particular data. Also, we have changed the call names for our understanding. Then we have seen that how we will be calculating the relative frequency. So this is how we can create the relative frequency. So this is there is no inbuilt function, so we have created our own function kind of thing. So this is our division operation, and here one operation is this sum, and another is this is calling one by one those value. Okay. After that we have once our both the analysis is done, we have saved this data as a external CSV file, and the file is stored to that particular location where the current directory is. Okay. And then then we have also seen that whatever the things we have discussed in throughout the lecture, how we can do that in just 2 or 3 commands. Okay. So this is how we can do that. So I request you again that whenever you are starting, if you are a very beginner with the R, you always go with this long way, because this is how you will get more understanding, and once you are comfortable in handling the functions and all, you go to the shorter way, and most of the times many of your bigger tasks will be solved in just one functions. Okay, we'll see that all those examples. In the second lecture, I discussed about the functions, how we can create the function. So for to create a function, we have to use the syntax like this. So to define a function, we have to give the name of the function, then assignment operation, then we have to call this function, and then we have to under those parentheses we have to give the what exactly the task we aim to do it in this function. Okay. And we have created lot many functions. Okay. Then we have discussed about the function based on single argument, then based on the 2 arguments. After that we have also discussed about that what output the function will give. Will it be all those operations you have given, or all the last operation? So we have find that the function will only return the last operation, and we have seen those examples here. And if you have to return the value after multiple operation, you have to do like this. So first you have to assign the thing that whatever the task is done, and then you have to call it as a last statement. Okay, whatever the operation will be in the last statement, the function will give the that output. Okay. So we have calculated this mean. First we have added all the frequency, and then we have divided by the number of observation, and then we have also seen that a straightforward function is there. So this is how we have calculated the mean. Then for median, we have just like to calculate the median, we have ordered the data. So it's up to you that whether you are doing in ascending order or descending order. So only thing you have to remember that for even number of values, the median will be the average of two middle values, but for odd number of observation, the median will be the middle values. Okay, so whatever the value is in the middle location, that will be the median. Okay. Then we have seen the median by a shortcut way. So there is a inbuilt function is there. We don't have to do all those things. We have to just simply call the function median. Then we have seen about this mode, because there is no inbuilt function is there for mode. First we have done manually. Then we have this we have created our own functions, and last what I have said in the week 4 also, that there are like multiple packages are there which have like large number of function itself for to solve the various problems. Okay, so instead of writing your own functions, you can use the other function which are already created by some other member of the community. So we have called this package dex tool. So that dex tool has a function named as mode, which gives you the value after calculating the mode of that particular data set. Okay. So in this lecture, I will be discussing about the measure of dispersion, and the similar way what I have discussed in the previous two lecture, I will be calculating the this measure of dispersion first manually, and then we'll do it in R. Okay. So if you remember, our data set was this. This was the year 2019, then 2021, 2022, 2023. This was frequency 1, 1, 5, 1. So in measure of dispersion, the first thing what we will be calculating is the maximum value. Okay. So if you see this data, so we can easily see that what is the maximum value. So the maximum value is 5. So here max value is 5. If we see this particular data, the minimum value is 1. So minimum value is 1. So we will be calculating the maximum and minimum value in R. So how we will do that? So just think of that, what will be the function name for calculating the maximum and minimum value. Okay. So what we have to calculate? The maximum, and then we have to calculate the minimum. So as I already mentioned that the function names are related to the task. So here if you see, for maximum, the function name is max, and for to calculate the minimum function, it's minimum. Okay. So there is no such function name is there like Mukesh, which calculate the maximum value, or Mohit, which calculate the minimum value. Okay. If you are totally new to R, okay, just think of that. What could be the function name? It could be maximum. Okay. This can also be possibility. A function can be a maximum, or maybe max, or maybe maxi. So we can try all those things, and whatever the things it will result, we can use that function. Okay. So let us assume that we don't know what function we have to use to calculate the maximum value in a data set. Okay. So we'll do like this. So I just do maximum on our data is df data dollar frequency. So a error is popped up that there is no such functions. Okay. Now if we go for our next function maxi, and I'll search here df dollar, and if I run this here, again for maxi there is no such function are there. Or let us take one more example. So I am assuming that there is a function called m which calculate the maximum value. But if there is a function named as m, so everyone will be confused. So m is used for maximum or minimum. Okay, that is why the maximum of the functions names are in such way that they are related to one specific task. Okay, so we'll see m also. Okay, so df det dollar frequency. If I run this, could not find function m. Okay, now we'll go to our next function name max. So if I see here, and the output is 5. Okay, so that is true. So whatever the value we have calculated manually, so it's the same result. So max is a function to calculate the maximum value in a data set. We have seen all those examples, okay, of possible function name. Similar way we will see the for minimum also. So for minimum value, say let us assume that there is a function called minimum, and now if I say okay, so there is no function either starting with minimum or minimum. Okay, okay, I have already mentioned that like the minimum in uppercase and lowercase will be different. So there could be possibility that there are some function names are there which are in uppercase with the minimum also. So we'll see that also. So yes, so there is no such function is there, whether it's in uppercase or lowercase. Let us try in all function name in uppercase only. Okay, so we'll try like min, and then okay. So there is no as such functions are available with the min name which calculate the minimum value in a data set. Okay, so min in uppercase there is no function, but min in lowercase is the function which we will be using to calculate the minimum value. Let us check now how we can do that. Okay, so so if I run this, I got the right value 1. That 1 is the minimum value in the data set. So max and min are the two functions which are used to calculate the maximum value in a data set, then a minimum value. Then in the next concept in the measure of dispersion is range. So what range is? Range is the difference of maximum value and the minimum value. Okay. So range is maximum value minus minimum value. Okay. So we have already calculated this max value 5, minimum value. So range will be 5 minus 1 equal to 4. Okay. So first we will not think of any inbuilt function. Why? Because now we have to just simply use the arithmetic operation. We have already calculated the maximum value, we have already minimum value, and we have to subtract that. and we will get the range. Okay, so this was our max value, and this was our minimum value. If I do this operation, I got this, and the range is 4. Okay, or what you can do also is that you can just assign this maximum value to here maxi. Okay, and this is maxi value, and then also what you can do here, you can mini. Okay, if I run this, now if I have to calculate the range, what I will do, I will call maxi minus mini, and if I run this, and it's saying that object maxi not found. Okay, what is the error it is? Can anybody guess? So if anybody can guess, just pause the video here and let us know in the discussion forum why this error maxi object not found came. Okay, so now if you see here that we just simply written the object name here, but we haven't run this object. Okay, so that is why object was not created. So we have to do first this maxi and then this mini. Okay, now if I do like this, it's again not, it's showing that maxi not created. So it's again showing maxi not found. Why? Because there is no such function called maximum, and I have assigned the object name maxi to a wrong function name. Okay, so what I have to do here is I have to just simply copy, or maybe we'll cut, and then this is our maxi. Okay, now if I run this, now if I again calculate the range, you will get the right answer this time. I hope so. Yeah, I got the right answer of value 4. Okay, so whatever the value what I have get earlier. So whenever you will be doing in R, there are possibility you will be finding some of the errors. Okay, during your calling the functions or something is missed. Okay, so you don't have to like worried about that. It's every time it's showing errors whenever you are running. Error comes. Okay, this is how we will learn that. Okay, if error is coming, something is missed. Okay, so if you see in this whole, just what are the example I was discussing, I faced 2 errors. Okay, first error was name the maxi object name to that value, but I haven't created. Okay, and the second error was that I have assigned the maxi object name to the wrong function name. Okay, and you see this error also, they are very like straightforward. One can easily understand that you have creating a maxi object to a wrong function. There a function doesn't exist. Okay, so I got the idea that where is that error is there. And if you see that to resolve these errors, I didn't went to internet or any kind of documentation. The whatever the error came, I just read the error. Okay, so this is the error, could not find the function maxi, or what earlier I got here, that object maxi not found. These errors are self declarative, that this error is because of this possible reason, and you resolve this and this problem will be resolved. Okay, so now we'll go to the next concept, is variance. So what variance is, we'll calculate here variance. So the formula of variance is variance equal to summation of xi minus x bar, your mean का whole square by n. So n is your number of observation, So what I will do, I will first calculate the x bar. So what our x bar is? X bar is mean. So summation of this 5 plus 1 plus 1 plus 1. So we will be calculating the xi minus x bar whole square. So this will be 1 minus 2 square. This will be 1 minus 2 square. This will be 5 minus 2 ka whole square, and this will be 1 minus 2 ka whole square. Okay. So this will be 1, 1. This will be 9, and then 1 minus 2 ka 1. So our this sigma xi minus x bar ka whole square came 12. So our variance will be 12 by 4. So it will be 3. So now we will calculate the variance in R. So how we will do that? Exactly we will do this operation. So let's do that. So we have already calculated the mean FQ. Mean FQ is our 2. So now we will calculate first xi minus x bar. So this is our x bar mean, and these are our values are there. So if I do like this, we got this value. Okay, we'll assign to this object. Now we have to square it this value. So how we will do that? So we'll use this way. So SMFQ not found. Why? So you see here SMFQ, F is capital, here F is small. So I have to give the this word. So if I do like this, I'll assign this to SQFQ. So SQFQ is there. Now we'll use the formula variance. So this is our sum of SQFQ. So this is that. It's 12. Now I will count the number of observations. So it's n 4. So it's 4. Now I divide those two. So our variance is 3. I got it. So whatever the output we are getting here, it's 3. And here also we are getting. So we'll assign this to. Well, now if I see the output of this variance of FQ, it's 3. Okay. So whatever the value we have calculated by manually, the same thing we have calculated in R also. So we got our variance. Now think of what could be the possible name of variance function. Okay. So it can be either variance, either on the uppercase or maybe the lower case, or like this. Okay, or maybe this it can be. Okay, you just give a try on all these possible function name, what could community can decide, and I just share you the like what is the valid function name to calculate the variance, this one. So we will be using this particular function to calculate the variance. So if I do here this, okay, so our variance is 4. But what happened is this, that our variance we have calculated, the value is 3, and now here the value of variance is coming 4. But why so? Is R is wrong or we are wrong? So neither we are wrong nor R is wrong. So what we have done is we have calculated the population variance. When we were calculating the manually, we were calculating the population variance. But for the sample variance, we have to use n minus 1. So in R, the function var calculate the variance of a sample. Okay. So that is why I am taking you first to the manual analysis, and then I am doing the in R. Okay. Because what function is giving, and behind that how that function is written, you must know. Okay. Then only you will have the good results, and then you can interpret the result. Okay, this is the sample variance. Okay. So for sample, what we have to do is here, we have to just simply give the length of frequency is n minus 1. So if I do like this, and if I now run it again, so our value came 2, and if I like this, but we haven't assigned. First we'll assign this to FQ, it's 2, and now if I do this, it's 4. But why it's coming 2 value? Okay, but we, our variance as per the R is 4. So let us now see what will get the variance value when we will be calculating the manually. Okay. So what we are doing here is, what is our sample variance is xi minus x bar ka whole square by n minus 1. Okay. So xi minus x bar ka whole square is, our value is 12. So 12 by n minus 1, n is our 4, 4 minus 1, that is equal to 3. So 12 by 3 equal to 3 4 ja, so 4. So now we are getting 4. So now here we are getting the right answer what R is calculating. So we can say that R is calculating the right variance of a sample. So what we can say here is that, so something is wrong is in our writing that those calculation. We will identify what is that mistake. So here if you see this sum SQ FQ divide by length df data, this our observation minus 1, but how it is calculated? So it is calculated like this way. So the way we have written those arithmetic operation, so there is something wrong in that arithmetic operation. What that mistake is? That mistake is this. So the meaning of this calculation is this. Okay. So if you are running in this way, it will calculate a different formula. Okay. So here you have to remember a very simple calculation, board mass. Okay. So what board mass is? Board mass exactly define the precedence of the operation. Okay. So here if you see in this particular here, first division happened. Okay. And then subtraction happened, because in board mass division come first. So division happened and then subtraction occurred. So that is why we are getting the wrong answer here. So for to correct this, what we have to do here is that we have to do like this. Now if I run this and if I check the value, it's 4, and our sample variance formula is also okay. So you have to be very careful whenever you are creating own operations in R. Okay, because our earlier operation was like this: sum divide by len minus 1. But what we want is sum divide by len minus 1. Okay, so there is a big difference in all these two operations. Okay, so you have to remember this whenever you are creating your own calculation. You just see that how that you are interpreting it. Okay, so that is why we are getting the wrong answers of variance. Okay, so I hope you have got the clear idea of how you have to create your own operations in R, and what is inbuilt functions in R, and what exactly that function is calculating. Okay, so the variance, the default function, the variance is calculating the sample variance. Okay. So now we will calculate the standard deviation, and we know the formula of standard deviation. It's a square root of variance. So whatever the value we have, so it's a square root of variance. So our variance is 4. So our standard deviation is 2. Okay. So we'll do the same way in R also. So how we will do that? So we have to calculate the square root. Okay. So there is a function in R for calculating the square root. What that function is? That function is so this function is sqrt. So sqrt is a function. If you want to know about sqrt, we will use the help. So this is how this sqrt function work. It calculates the square root. So as a beginner, I highly recommend that whenever you are calling any of the function, you must use this symbol question mark. Okay. So this will take you to the help and give you the examples that how exactly you have to call that function. What is the some of the examples are there. Okay. So this variance FQ we have already calculated. Okay. So what this was our 4, and now if I calculate the square root, it's 2, and the standard deviation will assign to this. Okay. So our standard deviation is 2. Okay. Now again the same practice. If we have to calculate the standard deviation, what function name it should be there? Okay. Any guesses? If you can guess any of the name of the function, pause the video here and let us know in the discussion forum that what function name you thought of. It will be the possible to for calculating the standard deviation. Okay. So to calculate the standard deviation in R, we have the function name st. Okay. So until now we could think of the function name by like our maximum. We could think of maximum, maxi, or max. But if you see that there are like operation is standard deviation. Okay. So that SD means standard deviation. So you have to think in that way also that okay, it's not always that we can have like std dev. Okay, we can think of that could be the function name, but how we will write that particular function. Okay, whether we will if like standard deviation is there, if we do like this standard deviation, then we'll call, so space cannot be there. So that is why you have to just give a try that okay, what could be the name of that functions to calculate the standard deviation. So if we run this 2, so our this and this is value is equal. Okay, and also like you can use that our logical operator. How we will do that? Simply and if I run this, it's showing true. That means the standard deviation what we have calculated without inbuilt function and the standard deviation what we have calculated using the inbuilt function is same. That means our operations are okay, and the standard deviation, the value of this particular data is 2. Okay. Now we will discuss about some of the other concept in measure of dispersion like quartile, percentile, and decile. Okay. So what quartile is? Quartile is the 25th percent of the data. So this like Q1, Q2, Q3. Okay. So this is just the 50%. Okay. And if you see the median is this only Q2. Okay. So Q1 is the 25%, then Q2 is 50%, and Q3 is 75%. Then we have this decile 1/10. Okay, 10%, 20% like that. And then we have percentile. Okay, 1/100. Okay, 1, 2, 3, 4. So this is how we can also calculate the this quartile, decile, and percentile on our data set. Our sample data set is too small, So, but we'll give a try on based on the what are the inbuilt function are there to calculate quartile or decile or percentile. Okay. So again, the same practice you do here also, that what should be the possible function name to calculate the quartile, decile and percentile. Okay. So if you have thought of that the function name of quartile or maybe this QUA or anything else, okay, you are going in the right direction. At least you are thinking that what could be the possible function name. But in R, the function name to calculate the quartile is quantile, okay. And how you have to call that function quantile is it's in this way. So we have to call this quantile, and then this is our data set, and what is like how we want to define it, like 0.25. This is the first quartile, then this is the second quartile, and this is the third quartile. If I run this, so 1 1 2, okay. Then if we have to only calculate the quartile one value, okay, q1, so we will be doing like this, okay. So this 0.25 means 25% only. So this is where we are calculating the quartile 1, and if we have to calculate the q3, we will be like using this. So whatever the output what we get here is the same way we get the output here, okay. So the value of q1 is 1, q3 is 2, okay. The same the answer what we have got it here, this quantile if we run here, that 0.5, 0.5 and 0.75. So what this mean is we are calculating the q1, q2 and q3, and if we run this, so the same value we have got. So if we want to know that okay, what exactly this quantile does, okay, so we'll again use this question mark sign. So we'll see what exactly it calculate. So this function is a generic function, it's the all details are given here. So this is how you can calculate the quartile in a data set. Now we'll discuss about the decile. So decile is basically dividing the data set in 10 equal parts. So here when we call the function quantile, we have assigned the value to probes is 0.25, 0.50 and 0.75 for calculating the q1, q2, q3. What will be the value of this when we will be calculating the decile? Okay, so this is given in that if you see the help, it is given there all the details about this particular function, but just you can think of then when we are using 0.25, 0.50, 0.75 for q1, q2, q3, what could be for decile? Because decile what exactly it does, it divides 10 equal parts, okay. So it will be 0.1, 0.2, 0.3. So this you can write in two way in R. So one is way is a longer way, just like the way we have written this. We'll see another way is using some functions are there. So we'll see first by writing this from 0.1 to 0.9, and then we'll see the shortcut way of writing this. Okay. So some error came. What that error is? So the error is this. We have put extra comma. What error is here is the error is that digits are greater than or equal to 1 is not true. Okay. What the issue is that we have to do like this. Okay. Because our syntax is this. Now if I run this, okay, we got the results. But see, in this way there sometimes the problem, like the way I got the error, it can comes. Okay, so also try to use many of the functions what we have in R by default. So to do this, what exactly we are doing here is, we are saying that this is a sequence. So the sequence from 0.1 to 0.9, and there is common difference is only 0.1. Okay, so you see each number is increasing by 0.1. So that is what we are saying, that 10%, 20th%, 30th%, 40th, 50th, 60th, 70th, 80th, 90th. Okay, so similar way, to do in a shorter way, what we can do is, we can use the function called sequence. So this sequence function generate the these numbers by defining that what will be the common difference you want. Okay, so here if we do like this, so if I so this sequence is that only. So sequence 0.1 comma 0.9, what it says, that create a sequence from 0.1 to 0.9 with a common difference of 0.1. Okay, if I do here 0.2, it will create a sequence of, let's see how it create the sequence. So it will be 20, 20, 20. Okay, so now if I run this, it's 10, 30, 50, 70, 90. Okay, it's not like 10, 20, 30. Okay, so this is how you can play with the data. Okay, how you want to calculate what exactly, like whether you want to divide the data set in 10 parts, or 100 parts, or the 4 parts. Okay, so in the similar way, how we will be doing for calculating the percentile. So we will be doing this is same way. So when we are calculating the percentile, we are dividing the data in 100 parts. So our first it will start from 0.01 and it will end to 0.99. So we are saying that create a sequence from 0.01 to 0.99 with a common difference of 0.01. Okay, so if I do like this, so this is my sequence is created. Now if I run this, my 100 percentile. This is how you can calculate the either the quartiles or the this decile or the percentile. Okay, so there is another thing what we used to calculate is that interquartile range. What exactly interquartile range is? So the interquartile range is the difference of quartile 3 and the quartile 1. So we will be subtracting the q1 from the q3. Okay, so this is our q1 and we will be subtracting into the q3. q1 we have already calculated. So our q1 is 1 and our q3 is this. If I run this, okay, now if I do q3 minus, so the value is 1. Okay, so now you think of any of the inbuilt function which calculate the interquartile range. Okay, so earlier when we used to calculate the either maximum value, minimum value, or the sum, we used to have this function max. Then we have min, we have seen min also. We have also seen SD in small for standard deviation. So these were like one word, maximum, minimum, and for standard deviation we have SD in lowercase. Okay, so what could be the possible function name for interquartile range? Interquartile range. Okay, so there is a common pattern where in the function name what we are seeing is that when there is a one word is there, we have the function name by the some of the letters of that word only, like max, min, sum, for summing up the number. But when we have standard deviation, square root, we have the function name in lowercase character, but one letter from each of the word, like SD, then SQRT. Okay, so here there are two letters. But if we think of in similar fashion, we could think of one possible function name is IQR. Okay, all in small. Okay, so let's see if there is any such function is there with IQR. So IQR, it is automatically showing that there is no such function with smaller case as IQR. So this IQR in uppercase is the right function name. Okay, so and then we don't have to calculate Q3 and Q1. If we are interested to know only interquartile range, we can simply call this function IQR on our data set and it will give the value. Okay, so the IQR of this is 1, and our earlier by when we were calculating by formula it was 1. So this is how we can calculate the interquartile range. Whenever you are using different function, you have to take care of these uppercase and lowercase. Okay, so not all functions are in lowercase, not all functions are in uppercase. So there are like mixed practice are there. Okay, there are functions are there. So you have to just take care of that. Okay, when you will be doing the practice, you will come to know that okay, this particular function is in uppercase for which we used to calculate the interquartile range. Okay, now let us move to other two concepts like skewness and kurtosis in our data set. So basically how much our data set is skewed or not. Okay, so for that we used to do calculate the skewness. So to calculate the skewness in kurtosis in R, we have to use some packages. So for this kind of analysis, we will call the package called moments. So first, if you have not installed that package, okay, so it's the first thing is that you install the package, and we have already learned that how we can install the package. So there is either we can call through command install.packages, or we can go through tools to install the package, or we can locally also we can install the package. Okay, so we will call this. If you haven't installed this moment package, you just simply install this moment package by using this command. So just I'll run this. Now you can call this by this library. Okay, so if I do like this our package is done. Now this is our data set. Okay, now if I have to check the skewness. Okay, so if I do like this, okay, so this is the value of our the skewness in the data set. So in the similar way I can calculate the kurtosis. So this is the value of kurtosis. So this is how you can calculate the skewness and kurtosis of in your data set. Okay, so until now whatever we have discussed is about only related to one variable. Okay, so what we have done until now is on the publication side. So our another variable can be the citation. Maybe we want to know that how these number of publication and number of citations are related. Okay, is there any relationships are there as a number of publications are there and number of citations in a year? So let's do that. Okay, so this was our data set. Until now we have discussed about this only single variable. Now this is our second variable, citations. Okay, for so in 2023 we have got one paper which have got one citation. So in 2022 we have 5 publication which have received like citation 2, 3 or 2, 1, and one paper doesn't receive the citation. In 2021 we have received 2 citation to 1 paper. In 2019 there is one paper where we have received a single citation. Okay, so now we will do include this second variable also. Okay, so our data set was this. We have already imported and we have given to name this. Okay, so these are the paper. Okay, and these are the year and these are the cited by. Now the column names we will just see what. So title, year, cited by. So now what we will be doing is we want to know that how much total number of citations in a year we got. Okay, like the way we have counted the number of publication in a year. Okay, for that what function we have used? We have used the table function. Okay, but for counting the citation we have to use this function called aggregate. So what aggregate does is aggregate, it is, if we do like this, so in 2021, like there is in 2019 there was one publication, it was cited by only one paper, and then in 2021 we have two citations, and in 2022 though we have five publication, but we have the these citations, some are eight, and in 2023 we have one. Okay, so this is our citation data. So if I see here this, and our publication data we have already has as frequency. So this was our number of publication in an year, 1151. So we'll add this extra column to our this dat site where we have citations also. So we'll have the number of publications. So we'll do this. So if I now check this, so this is what we have, the output is. What I have done is I have converted this data set into a format like this. Okay, year 2019, 2021, 2022, 2023. Okay, so number of publications in 2019 there is one, in 2021 there is one, then in 2022 there is five, then in 2023 there is one. Okay, now in 2019 there is only one citation, then in 2021 two, then in 2022 we have this these many five papers. So 2 3 2 plus 3 5, 2 plus 2 7 and 8, and then in 2023 we have one. Okay, so these are, so this is our now data set, and now we will be doing the analysis, and this I have done in R. Okay, so our data set is this. Okay, so when we were doing analysis on single variable, we used to do it for only this x bar, and then we put xi minus x bar, and then we do all the analysis. So here what we have to do is, first we have to calculate the x bar of this, then y bar of this, then xi minus x bar, and then yi minus y bar. Okay, because we have to do the analysis on two variables. So how we will do that? We will calculate, we have already seen manually of xi minus x bar of one variable, and in the similar way you can calculate that thing. And I'll request, if you are a beginner, you must first calculate manually on your paper, and then you go to the R. Okay, so we have the mean of the publication. So this is that, is 2, we have already calculated. So this is our mean of our publications. Now mean of citations, so we will be like this. So if we put the dollar, it automatically show me this. Okay, so I'll calculate this. So mean of the citations are 3, so average citations we have received 3. Okay, I'll assign this to an object MC. Now this is xi minus x bar. Okay, so I'll calculate this. So this is our MP1. I'll just write it down as a comment. So this is our x minus x. Okay, so this small x is our value, and then this is x bar mean. Okay, so this will be helpful for you. I'll be sharing this whole code in the GitHub repository so that you can also do the analysis. Then this is our y I minus y bar. Okay, then we'll calculate for this. Okay, then we also have the number of observations. So number of observations, we'll see how it is, like 4. So we'll assign to another object mn. So here you have to be very careful, okay, for this bracket and all. Okay, so what we are doing, we are calculating this. For covariance, we have a function called co. So if I do like this, so it's 6.66. This value is there. I'll assign to this. And if I now check the value, let's see. So again, if you see, if I do like this, either I will put first frequency and then the citations, or maybe first citation and then publication frequency. Okay, so the covariance is same. Okay, so the covariance between x and y or y and x will be the same thing. Okay, so this is a conceptual thing. You, I think you might know those things. But we want to know that how much the correlation is there between that. Okay, we have the functions for to calculate the correlation also. So first we will be calculating manually in R. We will not using the inbuilt function. So we will be calculating the standard deviation of citation. So we will be using this function, and this is our standard deviation of citation. Now this is our SDPC. What SDPC is? SDPC is covariance. Okay, and this is our SDFQ. We have already standard deviation of our frequency, and SDC is just now we have calculated standard deviation of citation. So if I run this, so this is our correlation. Now as we have the function for like every of the operations, we have a function called core for calculating the correlation. So if we do like this correlation, so we got the same result. Okay, so this is all about the descriptive analytics. So in the last 3 lectures I have discussed about how we can do the descriptive analysis in R by creating our own functions, or by step operations, or by using the inbuilt functions. Okay, we have also seen that we can use the packages also. There are some packages are there for specific tasks. So like what we have called the package called moments for calculating the skewness and kurtosis. So now I request you all to, as a practice, you give a try on this practice data set, which I'll be providing on the GitHub repository. You download this data and do all the analysis whatever we have discussed in these 3 lectures. Okay, so you just calculate the frequency of publication in each year, which year has the maximum number of publication or the citations. Then you also calculate mean, median, variance of publications and citations, whether is there any positive correlation is there, or negative correlation is there, or there is no correlation between publication and citation. Please let us know through discussion forum on this practice data set. So in the next lecture I'll be discussing about how we can use R for other like theoretical load, like Bradford load. Okay, so I'll discuss with some sample data set, and I'll also share that data set with you for your practice. So see you in the next lecture. Thank you.